By 1943, Japanese fighter models were meeting increasingly deadly opposition in the Pacific. Early design priorities, lightweight frames and superior agility, had become dangerous weaknesses. Encounters with allied aircraft triggered major technical changes in Japan's aviation strategy. Early Zeros, such as the A6M2 and A6M3, had no self-sealing fuel tanks. Their wing and fuselage tanks would erupt into flames after only a few 50 caliber impacts. With the arrival of the A6M5, Mitsubishi finally installed laminated, rubber-coated fuel tanks. These were positioned mainly around the fuselage. Although less effective than their American counterparts, they marked the Zero's first real fire prevention system. The upgrade came directly after studying damaged, but still intact F4F Wildcats and P-40B Warhawks. Originally, the Zero's philosophy traded pilot protection for nimbleness. By late 1943, combat data showed alarmingly low pilot survival rates. The A6M5 or HER model introduced a 45mm steel armor plate and an armored glass windscreen, though both remained lighter than US standards. The newer J2M Raiden included heavier seat armor and plated rear fuselage sections. These mirrored features on Allied fighters like the F6F Hellcat, which frequently returned from battle with cockpit hits that would have been fatal to earlier Zeros. The first generation Zeros also had structural limits, failing in steep dives beyond 400 knots. To counter this, the A6M5 featured reinforced wing spars and 5mm thick wing skin, pushing the redline speed to 460 knots. The Kawanishi N1K2 also used a simplified but high-strength frame, increasing load tolerance. American dive tactics, especially from P-40 and F-6F pilots, exposed the lethal vulnerabilities of older Japanese airframes, spurring these reinforcements. Against bombers like the B-17 and B-24, early Japanese fighters' light guns were inadequate. The A6M5 added two 13.2mm Type 3 heavy machine guns to complement its two Type 99-20mm cannons. Both the Raiden and N1K2 carried four Type 99 Model to 20mm cannons with better ammo feeds. This was a direct counter to the 650 caliber guns in Hellcats and Mustangs, aimed at improving kill chances in head-on and tail-chase attacks against Allied bombers. The Mitsubishi Kasei 23 radial engine in the J2M initially had heat regulation problems at low altitudes. This led to a redesigned cowling with new intake geometry, added cooling gills, and enlarged oil coolers. These adjustments were inspired by captured P-40s using Ellison V1710 engines with turbo-supercharged intercoolers. Although not as efficient, the Raiden's airflow upgrades greatly reduced engine seizures in tropical regions. Early Japanese cockpits featured high rear decking and framed canopies, limiting rear visibility. US fighters like the P-51B and P-47D introduced low-profile bubble canopies with minimal framing. The Nokojima Ki-84 and Kawanishi N1K2 adopted cut-down fuselage with clear bubble canopies, giving pilots far better side and rear views in high-speed combat, an idea borrowed from US escort fighter tactics. Over the skies of the Philippines and Marianas, the J1M1's Gecko night fighter carried the Type 3 Ku-6 air-to-air radar, with dipole antennas mounted on nose and wings. This primitive device was Japan's answer to the SCR-520 radar seen on P-70 Havocs and modified Avenger patrol aircraft. Its effective range rarely exceeded 3 kilometers, but it allowed some night interception attempts against B-29 bombers. Japan's radar development expanded in 1944-45, but it was far too late to stop US nighttime bombing operations. In earlier years, Japanese fighters emphasized tight turning ability and rapid climbs. Late war design shifted toward roll, rate, durability, and energy retention. The J2M Raiden was built with a short, reinforced fuselage and high wing loading, trading maneuverability for superior high-speed climbing and diving power. The N1K to Shiden was a streamlined redesign of the N1K1, reducing maintenance needs and improving toughness, featuring inline shock absorbers, stronger landing gear struts, and better roll control. Both designs arose as direct counters to the rugged, heavily armed US fighters that had outlasted and outgunned earlier Japanese aircraft. From fuel safety to stronger airframes, most of Japan's late war fighter upgrades came from studying US planes directly. Captured wreckage, field intelligence, combat analysis, and evolving battle conditions pushed Japan away from lightweight dogfighters toward heavier, more survivable machines. Though these changes came too late to alter the war's outcome, they reveal a story of rapid wartime adaptation driven by necessity and shaped by the very opponents they were meant to defeat. Thank you for watching, and please support my work by purchasing my ebooks. You can find the links in my bio or by searching Adrian Lamford on Amazon.